I will give you an introduction to some of the software that are running on the robot. And on our wiki we have an overview of the software, and it looks like this. You have seen it before, I'm sure. So there is some software on the microprocessor. I will not use much time on that. It's a Raspberry Pi. That's the closest to. That's where you are going to make some new software that can control the robot. So basically, that's what I'm going to tell about. Two major pieces of software. There is the mission part, which is probably where we're going to spend the most of the time. That's what controls the missions. And the Robobot bridge, that's what connects the GUI and the mission to the actual microprocessor. And that also integrates the remote control with a gamepad and the small display. So we'll start with the bridge software. And if we dig into that, then this is an overview of what that one is doing. So that's taking the baseboard, the motherboard of the robot, microprocessor, which is talking to the Raspberry Pi using USB. And there is a block, which means a class, that handles the connection to the robot. There is another class that interfaces to the joypad, to the remote control, and there's yet another class that controls the line display. All the information back and forth are handled by text lines, so everything is in clear text to make it easier to debug. And whenever there is a new message from anywhere, it's handled by a class called handler, and it will put the data into a database called data here, which stores data items, and data items, that's just text lines. And for each data item, you can subscribe to the data at regular intervals, or you would like to have all updates and sent to a client. It will never, and the clients are on a TCP/IP port, and the default is that I have a port number 24001, and if you connect to that, you are a client, and clients can subscribe to data items, and it can send messages back, and the messages back is also text lines handled by the handler, put into the database, and if it is for and it also handles if this data is a type that needs to go to the display, so you can send data to that. You can send data to the robot, which is the most common one, and you can tell the bridge to do something. That means if you want to subscribe something to one of the data items, it's handled by the bridge, and it will insert your request to the relevant data item. If it doesn't exist yet, it will create it. So that if there comes data with that keyword, then you will subscribe to that. And all these data items, data lines, start with a keyword. And that's how it's stored in a database and indexed and whatever you need. It's not a real database, but it is something that everything is handled in RAM, and it is not as complicated as a real database. It's much simpler than that. So basically, this is, I will not go very much further into that, but there is on this wiki page a number of descriptions, or a bit of a description and some examples of different things. And but I will show you how it works in real life. So I will connect to the robot. I have a robot standing here next to me, and it is turned on. So we'll connect to that one. And of course the robot has to have the software. And if I say ls to see what do we have, we have a link. In fact, it's a link, but it looks like a directory called Robobot Bridge, and we will go into that. Robobot Bridge, and if I say ls in here, there is a number of files. One of them is called main, which is the main where this software starts, and there is one called Regbot H and Regbot CPP. That's the class that handles the interface to the robot. There's one called, where is it? It's here, OLED, a CPP file and an H file. That handles the OLED display, the small display in front. And there's one called Joy. That's a remote control, the joypad or gamepad. And and there's a number of support files. There's one called handler, and that's the one that handles, sorts all the messages, puts it into the database. And there's a database here and data items. So basically this is it, and it needs to be compiled if you're going to change it, and that's put into the build directory. The instructions to how to compile it is in the cmake list.txt, because this is a cmake type where you can see what's in that file. I will not edit it, but I'll just show it. Cmake text. So this is the description of what it needs to do to compile it. And there's a lot of things here. Find package, OpenCV, and it uses threads. So it also needs to find that package. And there's some include directory and a little bit more than that. Add, and down here add executable. It's called Robobot Bridge, and it has to compile main and all these other files to make the full application. And it has to link cmake thread libs init. Yeah, okay. It's probably fine. I probably made it myself, so but I don't quite remember everything that's in there. And there's a build directory, and if we see, are there anything in there? Yeah, cmakes make a make file, and that's the one that describes how to compile everything. I'm not going to look into that. It's all too complicated to do that. Cmake creates it, and that's fine. That's sufficient for me. If you want to compile it, we say make. And it says it's built already. I can say make clean to remove everything it has made, and then I can do it again. -J5. So it will now compile it, compile everything. And nice, yeah, it's running as fast as it can. It has only got 4 cores, but I started 5 threads, but it now is finished with compilation and has made this green file here, Robobot Bridge. I can run that, but it's running already, but I can kill the one that is running. Sudo pkill bridge, and I need a password to do that. And now it's not running anymore, but I can run it. It needs to be run as root or with administrator with super user privileges. Robobot Bridge, and when I run it, I can see what is displayed on the small display. you can see it here. This is what is on the small display, and here is also shown the IP number that the robot has. I can say help, and I get some help here. And when I connect and put in the right then when I connect this, I will actually connect to the bridge, and we should be able to see it on the other screen that it is connecting. And it replies that this is a lot of items, and it just means that there is no responder, and that means there's no data item in the database yet for all these message types, but it's then created. And whenever I do something in the client, something happens over here, and in the bridge, say S for status, I will get a list of all the data that are already in the database now. HBT, heartbeat, and this is all the parameters in the heartbeat message. And one of them is recognizable, and that's the battery voltage. It's now down to 11.17 volts. And that should be the same that I can see in the GUI. So we'll have the GUI. It has rounded it to 11.2 volts. So, yeah. So this was just to show what the bridge is doing. I will not go any further into that. I will leave it running because I've killed the other one. So this one is now servicing whatever is needed. So now I'm back at Robot and looking at the directories, and there's another one called Mission. Well, maybe I should start with, there's another one called Regbot, and that's blue. That means that it's a directory. And if I go into that and see what do we have of files in there, well, there's a lot of directories, because this is basically all the software that are made for this robot, whether it's used or not. And one of them is called Robobot Bridge, and that's actually the one we were in before. And there's also one called Mission. So there is everything in here, but that's all too complicated. So we'll go back a little bit and say ls minus L, and this is the directories, and we had this Robobot Bridge, and you can see here it's actually a pointer or a link, symbolic link to exactly this directory in this Regbot Bridge. So instead of going in here, we can just use the other one. And the same with Mission, so that's also in there. We will have a look, go to the Mission, and see what we have got of files in there. And just as before, we have got a lot of CPP file and H files, and there's also one in here that is called main. It's over here, which is the main file, and we will have a look at that and have a look at some of the other files in there. I will not look on the Raspberry Pi. It's a good idea to make a copy on your PC when you need to change a lot of files, and then copy them to the Regbot and compile it there. And just as the other one, there's a build directory here, and if we go into that, build and have a look, we can see we already have a mission, so it is compiled. Whenever we change something, it needs to be compiled again. If I say make, it's probably already made. Yeah, it is built already, so it doesn't do anything. It checks all the dates, the timestamps on all the files, and they are all older than the mission file, so there's no reason to recompile it. Mission software, and we'll go into that and have a look what is in there. And this is an overview of the software, and this was all the files that you saw we had before. And we have an interface to the bridge, the Robobot bridge. We saw that earlier. This is this yellow block. All these bluish ones are the one we have in the mission software. So we need, of course, an interface to the bridge, and that is called bridge. Yeah, it isn't the bridge, but it's the connection to the bridge. And that's connecting to this port number. So all the communication goes through this class, and that can then send to the bridge. To make it simpler, we don't need to establish that connection already. And the bridge, whenever it receives something, it will see if it knows what to do with it. And there's already a number of classes here that can handle some type of messages and subscribe to the data from the bridge. That means in reality from most of it from the robot. But these are the ones that are there already. And there is an IMU block that takes data from the inertial measurement unit, that means from the gyro, accelerometer and stuff like that. And it will store the data that comes with these messages in this block. The same with the infrared distance sensor, with the pose, where is the robot, X, Y, and heading. And it also has, this pose also has the tilt value, how much is it going uphill or downhill. So that information is in here. What is the joystick, the gamepad, all the buttons on the gamepad. We can get messages of that, and that is stored in this one. So if there's a key pressed, this goes into this block. There's the motor data, the velocity and current of all motors coming with this message if we want it. There's some other information like battery and time from the robot. And then it can handle events. Events is important. This is handled in here. When we want to start something or react on something in a mission, that is typically an event. The edge, that's a line sensor. And that's something like, is a line valid, is a crossing line valid, we can get that information directly here. We saw there was a main file, and that's the one that starts everything up from the command line. When we want to run a mission, we start this app, and the main will then initiate and create all this. There's a camera interface that can take images from the camera, and there's a skeleton. This is probably one of the places where you need to do quite a lot, because this year's mission we sort of really need the camera. So some parts are done already. And then there's the mission, which sort of orchestrate everything, and we need a really long mission, much longer than we can do just using the GUI. There is a mission here in the GUI, but it can only handle a few lines at a time. But we can continuously send new mission lines to the robot, and that is handled by this block called mission. And from here we can also control other stuff, like the speaker. So we can make it speak something, or we can start some music or whatever, and we can connect to all the support that the Raspberry Pi can do. Yeah, we will have a first look at the software. If I go to the beginning here, there's a lot of include, a lot of stuff, but there should be a function called main. That was. So this is a C++ program directly. So there must be a function called main. That's where everything starts. So this creates whatever is needed. And the first one, command line parameters. There's something that can be changed from the command line. If everything is okay, then we will start all the classes or create all the classes. We will connect the bridge, connection to the bridge. We will start a camera class. We will start a mission class. We will start the camera. The camera is called cam, and we start that. That means that it runs its own thread. And we'll start the mission, and the bridge will then create all the others. Then we will sleep for 1 second, just to wait for things to be created and the connections to be established. And then we enter a loop saying while the mission is not finished. Then we will get a line from keyboard. If there is command from the keyboard, then we can handle that. Mission start, and that will start the mission that we have coded into this class. So the mission class, that's the most important one. We will find that is in. So the mission will have when it started, have a connection to Regbot, which means actually the bridge, and it will have a connection to the camera as the two most important support pieces or things that it needs.